Okay, this is going to be the first of two videos I'm going to have on Cournot Duopoly. This is going to be in part one here. We're going to look at how each firm or how one firm is going to make a decision based on the based on a choice by the other firm. So the Cournot Duopoly, the example that Cournot gave was that perhaps you have a natural spring, and there are two firms or two companies that have the ability to take water from this spring and bring it to a town, bring it to a nearby community to sell. And so we have a market demand curve for the spring water, and here it is. And I'm going to use the same numbers here that I have in my notes. So this is a video that's literally going over the exact same example I have in my notes. This would be exactly what we would be doing if we were having class. So I'd go over this on the board in class. So the demand curve for spring water is 30 minus Q. So we've drawn this in here on both firms' diagrams. I guess I should write here that this is firm A. They each face this same market demand curve. And what we'll assume is that we have barriers to entry beyond this. We have a duopoly. Duopoly means two firms. So duo, two, play on the term monopoly. So we have a duopoly here. We have two firms. There are barriers to entry, so a third firm can't enter in this. But we have a complication that we didn't have in either perfect competition or monopoly, and that is that there is another firm for firm A. When firm A is trying to figure out what they are going to do, there's this other firm there, and they have to take into account what firm B is going to do or might plan to do in making their own plan. And what we're going to end up doing here is actually think of this as a game. And what we're going to do is we're going to end up solving in the course of two videos for the Nash equilibrium of this game. So if firm A was a monopolist here and there was no firm B, well, facing this linear demand curve, we draw in the marginal revenue curve that would be twice as steep, since the demand curve comes over and intersects the x-axis at 30. I mean, the marginal revenue curve would come in and intersect at 15. And then since the marginal cost in this case is 0, then marginal revenue equal marginal cost. This firm A, if they were a monopolist, they'd provide 15 units of water to the community, and then they charge a price of $15, and they'd make a profit of $225, 15 times 15. And so that would be the end of the story if this was a monopoly. But we have firm B. And now firm A has to make some guess about how it is that firm B is going to operate. And before we make that guess, one thing I do want to mention is that when we write out the demand curve, what we can do is we can substitute for the quantity, the total quantity in the market, with QA plus QB. And when we do that, we're actually assuming that the customers here are viewing the products of firms A and B as perfect substitutes. Okay, so they would be added in here together, and that would give us a demand curve. In the chapter, they go through an example where you could have an example where there's a competition between the firms and their products are imperfect substitutes. We're not going to do that, but when we simply add QA and QB together, we are making an assumption here that the products of firms A and B are perfect substitutes for each other, which sort of makes sense given the example that Cournot gave. It was like they're both getting water from the same spring, so it's the same spring water. They put different they put it in different bottles with different labels, maybe, but it's the same water from the same spring. That's why it would make perfect sense for the firms to be perfect, for these products to be perfect substitutes. Okay, so here we are. What are we going to do? Firm A has to make some kind of conjecture or think about how it is that firm B is going to behave, and then try to figure out, well, if B does this, this is what we're going to do. Okay. Cournot assumed that the way these firms would engage in competition is they would make these plans or conjectures about the other firms' behavior in the form of quantities. And so they are engaged in what's known as quantity competition here. Firm A is going to say, okay, let's guess or let's suppose that firm B is going to provide a certain number of units to the market. Okay, given that, then what quantity would we want to supply to the market? So to see how we would do this, we'd have to we would need to write in here to begin with. We have to make some guess about what firm B would do, and I'll actually use the same guess as I had in my notes, and then I say, well, suppose that firm B is going to produce 6 units of the good. So firm A just guesses, okay, firm B, let's say they're going to supply 6 units to the market. You know, if they were a monopolist, they'd be providing 15, but let's say they happen to guess, they happen to choose 6. So firm A sends a little spy over. They see like, oh, firm B is bringing 6, a quantity of 6 to the marketplace. If firm A happens to know this, then what quantity would they want to provide? Well, first off, we'd have to say, how does this affect the demand curve for firm A? Well, it turns out to be the case that with this quantity competition, the way it happens is that it's as if you could subtract 6 off the demand curve. And to see that, you could say, well, suppose you set QB equal to 6 and then rewrite the demand function. For firm A, that would be, was it 30 minus QA minus 6. And if you simplify that, then it would be Q equal 24 minus QA. So you have 24 minus QA, and that would be the demand if firm B provides 6. That's the demand for firm A. So what we come out here and is if we shift this market demand curve in or down by 6 units, by the amount that firm B is going to provide. And so we come down here, this would be 24. This would come down here, you shift this in 6, that'd be 24. And draw in I'll call this here D minus 6. D minus the quantity that firm B is going to provide. Okay. Well, if this is still this market demand curve is linear, so if we subtract 6 units off it, this demand curve is still linear. And so then what we would have is if facing this purple demand curve, the firm A would draw in a linear marginal revenue curve, and it would come down here and it should intersect the marginal cost curve, which happens to be the horizontal axis, at a quantity of 12. So what we'd be able to say here is that what firm A would be saying is that if firm B produces 6, it will produce 12. And the way we got that was, again, we simply figured out what's the profit maximizing quantity for firm A to produce given some arbitrary choice of firm B. Now, the choice of 6 for B was very arbitrary. I just made that up. One thing we could do is think about repeating what we did here for lots of different quantities for B. We could say, like, okay, what if it's 2? What if it's 12? What if it's 20? In each of those cases. And then come over, redraw the demand curve for firm A, and then figure out the profit maximizing quantity for each of those different demand curves, for each of those different choices by firm B. That's what we're going to do. We're going to pick this up with a second video that will jump in to a different diagram and and write this out as a formula instead of repeating this exercise 30 times for each different quantity perhaps that firm B could do. So that'll be our next video.